This function is called the gamma function, and here k is a positive number. And so the function is t to the k minus 1 times e to the negative t. And so, for example, gamma 1, that's when k is 1. And so in the place of k, we have 1. So we have 1 here. And t, 1 minus 1 is 0. So t to the 0 is 1. And so we just get e to the negative t. And this is an improper integral. So we can rewrite it as the limit of this integral as b approaches infinity. The antiderivative of e to the negative t is negative e to the negative t. And then evaluating from 0 to b. And so first, let t replace t with b. We get negative e to the negative b. And then the lower limit of integration is 0. And so we have e to the 0. Negative e to the negative b is the same as negative 1 over e to the b. And then this becomes plus 1. As b approaches infinity, negative 1 over b approaches 0, so we get 0 plus 1, which is 0. And so gamma of 1 is 1, and that's when k is 1. And now let's find gamma of 1/2. And so in the place of k, we have 1/2. One half minus 1 is negative 1. T to the negative 1 is the same as 1 over t to the 1/2, which is the same as the square root of t. And now let x be the square root of t. Square both sides, we get x squared is equal to t, where t is equal to x squared. The derivative of t with respect to x will be 2x, or dt is equal to 2x dx. And so this integral now becomes this, t to the negative 1/2, which is 1 over the square root of t, but the square root of t is x, so we get 1 over x. T is x squared, so e to the negative t will be e to the negative x squared. Dt is 2x dx. This is the multiplication constant 2, so we can move it and place it in front of the integral. X dividing by x is 1, and so what's left is e to the negative x squared dx. This represents the area from 0 to infinity. This is the graph for the function e to the negative x squared. This integral right here, the integral from 0 to infinity, represents the area from 0 to infinity. So the area under the graph, between the graph and the x-axis, from 0 to infinity. If we multiply it by 2, then we just double this area. And so here's doubling the area. So this area, or this shaded region, is 2 times the integral from 0 to infinity. Because the integral from 0 to infinity is the area from 0 to infinity. So we double it, and then we get this entire area right here. But this shaded region is also the integral from negative infinity to positive infinity. And so 2 times the integral from 0 to infinity is the same as the integral from negative infinity to infinity. And the reason is because the function e to the negative x squared is symmetric about the line y equal to 0. And so far we have gamma 1/2 is the integral from negative infinity to positive infinity. The variable x here is just a dummy variable. And so the integral, if we're using the letter x, then the integral from negative infinity to infinity for the function e to the negative x squared, this right here, this integral represents this area. But if we use the variable y, then the integral from negative infinity to positive infinity of the function e to the negative y squared is also this area, so it's the same area. So it doesn't matter what variable we use here. It could be x, it could be y, it could be z. And so now we do gamma 1/2 squared, which is gamma 1/2 times gamma 1/2. So this gamma 1/2, that's the integral from negative infinity to infinity with the function e to the negative x squared. And then this gamma 1/2, we can write it as the integral of negative infinity to infinity with the function e to the negative y squared. And now notice the following. The double integral of e to the negative x squared minus y squared. And if we look at the inside integral right here, is with respect to x. So e to the negative y squared, it just is a constant, is considered a constant. And so here is a multiplication constant. So we can move it and place it in front of the integral. And now look at the outside integral is with respect to y. But this piece here, there's no y here. And so we can consider it as a multiplication constant with respect to the outside integral. So we can move it and place it in front of the integral. And so the integral of e to the negative x squared dx times the integral of e to the negative y squared dy is the same as the double integral of e to the negative x squared minus y squared dx dy. And so gamma 1/2 squared, which is equal to this, but we have just shown that this product here is the same as the double integral. And so this product of integral is the same as the double integral. And in an earlier video, we have shown that this double integral right here is equal to pi. And so to see this video, see the description section of the video link. And so gamma 1/2 squared is pi. And now take the square root of both sides. We get gamma 1/2 to be the square root of pi.